All right, greetings everyone. Welcome to the first part of the video for section 6.4. And in this section, we'll start to expand our study of trig functions and trig equations, start to look at solving trig equations. By the way, make sure you please take a minute to enjoy this meme here because it is one of the absolute best for what I have for this class. All right, hopefully you enjoyed that. Let's move on then. So down below, I have two separate things. So one problem that says to evaluate inverse sine of root 3 over 2, and then another one that says to solve sine of x equals root 3 over 2. And we're asked on this slide to identify the similarities and differences between these two problems, and also to look at how the solutions to each are related or not related. So let's take a look at this. So first of all, let's start with the top one. So we're asked to evaluate inverse sine of root 3 over 2, which we looked at evaluating inverse trig functions in the last section. So recall that inverse sine gives us answers in the first and fourth quadrants. But we know here we see that the sine value we're given, that root 3 over 2, that's positive, which tells us we're looking for something in the first quadrant. And if we think about where sine is equal to root 3 over 2 in the first quadrant, the answer there is pi over 3. Okay, so our answer there is pi over 3. All right, now let's look at the second one. In the second one, we're asked to solve sine of x equals root 3 over 2. Sine is root 3 over 2. Well, from the problem we just did, we know that x, in this case, could equal pi over 3. Let's also think about, could that be the only answer to this problem? Is that the only possibility for x? And if you think about that, you probably are saying, no, there are more possibilities, Cody. In fact, here x could also be 2 pi over 3. Okay, so we know that sine is also positive in the second quadrant. And in the second quadrant where sine is equal to positive root 3 over 2, that answer would be 2 pi over 3. And if we think about this some more, there's actually more answers we could have here, right? Because right now we've got an answer in the first quadrant at pi over 3. We also have an answer here in the second quadrant at 2 pi over 3. And we've kind of started, at pi over 3, we went around to here. But you can also imagine that if we went around the circle a full revolution, back to pi, the location of pi over 3, we could get another answer, right? So we could get an answer from starting at pi over 3 going a full circle, which in that case, that would give us 7 pi over 3. Then we could also continue around the circle again back to the position of 2 pi over 3, which would be another spot, excuse me, and have an answer is 9 pi over 3. And as you can imagine, we could continue on from there. So it looks like the second one has, in this case, an infinite number of answers. So going back to the original questions, what are similar or difference about these two things? Well, we see that both of these problems have pi over 3 as a solution. And in both, we were looking for an angle whose sine was root 3 over 2. But in the case of the second one, we ended up seeing there were actually an infinite number of answers. Whereas the first one, because of the restricted range of inverse sine, we only got one answer. Okay. All right. So this leads us into solving basic trig equations. So in this one, we're asked to solve sine of theta equals 1/2 for all solutions in the interval 0 to 2 pi. All right, so notice right here, we're asked in and on the unit circle, right? So we're thinking about where is sine positive, which again is in the first and the second quadrants. And so we're only looking for, think about our unit circle here, again, we're only looking at values that would lie on there. So where in the unit circle is sine equal to positive 1/2? Well, from my remembrance of the unit circle, that happens at pi over 6 and then 5 pi over 6. Okay. So those would be our solutions here, right? Because those are the only places between 0 and 2 pi on the unit circle where sine equals 1/2. All right, cool. Well, let's look at this next problem then. Here we're asked now to find the sine of theta, or excuse me, to solve the sine of theta equals 1/2 for all solutions now. And as you recall in that one that we did at the beginning, right, there was an infinite number of ways or infinite number of possibilities to solve or to find values or angles that had the given sine. And so we have a similar situation here because as you can imagine, right, if we start at pi over 6, we could be doing many revolutions going around the circle, stopping at that same place every time. And every time we stop, we would get a new coterminal angle that has the sine of 1/2. And also keep in mind, we could spin backwards too, right? So I keep spinning counterclockwise, but we could spin clockwise from pi over 6, again, as many times as we want, and keep getting an answer that has a sine of positive 1/2. And we could also do a similar thing from 5 pi over 6, right? I could start here at 5 pi over 6, go a full rotation, and get to a new angle that has a sine of 1/2. Go another full rotation, have another angle as a sine of positive 1/2, and just keep going around. And we could spin the other way. So how will we somehow encapsulate that? Because it really, as you imagine, because seems to be an infinite number of answers there, we don't want to try to list them all out. And in fact, there would be no way we could do that, right? So how do we capture that in a kind of a more concise form? Well, starting with pi over 6, again, keep in mind that we can get more possibilities by continuing to spin around a full 2 pi. And we can spin around as many times as we want. And again, going either direction. And every time we do that, right, that's like adding 2 pi to pi over 6. And depending on the number of times we spun, right, that's the number of 2 pi's that we've added or subtracted if we're going backwards or forwards. So the way that we show that here is by doing pi over 6 plus 2 pi k. And so what that's telling us is to start at pi over 6, add as many values of 2 pi as you want, or subtract as many values of 2 pi as you want to get more solutions. And as you can imagine, a similar thing will work for 5 pi over 6. If we add 2 pi k, then we will get more solutions. Okay? And in this case, if you want to get really technical about it, we do have to add in that k is an integer. Remember, integers are positive or negative whole numbers. So what we're really saying here is add or subtract full values of 2 pi, so full circles. And generally, we don't need to include that extra k as an integer part. That's kind of implied, but if you want to put it in or wondering more about what that value of k represents, that's it. But the thing I boxed there, that is a completely reasonable answer for this. All right. Okay, that's it for now. Thank you for watching.